If you read the announcement of JDK 26, it looks like a release most enterprise teams should simply or would simply skip. It's not an LTS version, and there are zero features graduating to final status. But if you ignore it, you're leaving serious performance gains. Yes, we are talking performance and Java, especially for your containerized workload. So why does a Java release with no new feature actually matter so much for enterprise customers? To discuss that, we have with us once again Simon Ritter, Deputy CTO at Azul. Simon, it's great to have you on the show.
Yeah, it's great to be back again.
It's my pleasure. And today we are going to talk about JDK 26. Just talk a bit about anything new in this release.
Yeah, it's an interesting one because, of course, if we think about JDK 25, that was a long-term support release, which means that it's one that people are more likely to use and deploy in production because it has extended maintenance and support. So JDK 26 is not a long-term support release, but it is still one which contains new features and contains changes and so on. I would say that looking at the list of new things and things that are included in that, it's not one of the bigger releases, but it's also not one of the smallest releases. I guess one thing that is of note specifically about this particular release is the fact that no preview features, as they're called, or incubator modules, have been made final in this particular release. So that's just an interesting aside in terms of that. But I mean, if we dig into what kind of things are included in those changes, and there are 10 what are called JEPs, JDK enhancement proposals, and these are really the things that define the specific features that are being included. There's several which are just updates to existing features which are being developed. So they maintain that preview feature status. So if we look at things like structured concurrency, this is a way that the language is evolving to make life easier for people to develop multi-threaded code. It's notoriously difficult to create cooperative multi-threaded code. So this is a way of trying to ease that process and make code more reliable, I would say. We've also got an update to what are called lazy constants. They used to be called stable values. Again, this is an idea of looking at how we can change the language to make life easier for developers. It's also tied into another one of the new features here, which is called prepared to make final. And you kind of think to yourself, what does that mean? There is this idea in Java of final fields. Final field means that you set it once and you can't change it, or at least that's the theory. The reality is that although from a language perspective you can't change a final field, you can still change it if you use a thing called reflection. If you use deep reflection, you can access that field and you can change its value. That makes life difficult for the JVM. It makes life difficult in terms of optimizing the code to the maximum level that it can, if it still has to take into account that a final field might technically be changed by somebody using deep reflection. What they want to do is to do away with that, so that they're going to make final really mean final. So once you set a field to a particular value, then you cannot change it at all. That way we can optimize things more and we can get better performance out of the JVM for things like that. And that again ties back into what I said about the idea of lazy constants. Lazy constants is a similar concept in the sense that it's about having fixed values associated with a name. But the reason that we want lazy values in addition to final fields is that lazy values give you more control over when that value is assigned. And that can be quite significant in terms of the way that the language works and the way that programs deal with things. So final fields are going to become really final. And then we'll also have this concept of lazy values, lazy constants, which will allow us to determine when we want to assign a value to those. The vector API is still there. This is part of a bigger project called Valhalla. It's in its 11th iteration now, so that's been going through a long gestation process. There's no real reason that it needs to go through that length of changes. There's not a lot of work going on there. It's more to do with the fact that the developers have actually said that until other parts of Project Valhalla come out, which maybe another year, I would expect, then we won't see the vector API becoming final. Some other changes around existing sort of preview features, as I said, such as primitive types in patterns and instance of. This is an interesting thing, because if you look at the way that the Java language works, you have the concept of primitive values and you also have types, so classes and objects. And the reason we have primitives and not treat everything as an object is to get better performance again for applications. Now, what they've done is they've said that having introduced pattern matching for instance of and switch in earlier versions of Java, that only worked with a full type. So it had to be a proper type in the sense of Java. What they've now allowed you to do is use primitives in those things. But when you put primitives in there and you mix them with types and wrapper classes, so you've got an int and an integer, things can get a little bit complicated in terms of trying to identify, which precedents you have and how things are ordered. So they've had to go through, and there's a lot of edge cases that need to be analyzed and corrected for that. So I think that's a good thing that they're still working on that. A couple of other things that they're doing in JDK 26, removing the Applet API. Applets were the thing that really kind of made Java famous back in 1996, 1995, I should say, when it was first launched. And they've never really kind of been popular after the first few years. Java has very much succeeded on the server side, not on the desktop. Everybody uses JavaScript, CSS, and that kind of thing. So what we've seen is that applets are very much legacy application code. None of the browsers support applets anymore. The browser plugin, which is what you would need to run applets, has been discontinued from JDK 11, but they left the API that was there for applets in the class libraries, and now they're finally tidying that up and actually just removing it completely. Some performance things that they're including. So there's some improvements around what's called the G1 garbage collector. They're reducing synchronization that's associated with that. It's quite a low-level feature, but it's designed to improve the efficiency of the garbage collector if you're using that particular one, so that's a good thing. There's also the inclusion of what is called PEM encoding of cryptographic objects. This is to do with if you want to send email and you want to encrypt that email, there's now an API that allows you to do that directly so that you can handle the cryptographic keys for dealing with that from your application code. So that's a nice inclusion there. Another small thing is an API specifically for HTTP3. And this is, again, higher performance. Rather than using TCP as the connection protocol, it uses UDP in a reliable way. But again, it's just about improving the performance of things. And so I think that really, I'm trying to think if there's anything else that I've missed there. I think, structured concurrency. I think I already mentioned that one. But that's really what we have in JDK 26. So no kind of earth-shattering features, but it's, again, just a general evolution of the platform, keeping it moving forward in a direction which helps developers in various ways.
Can you walk us through the performance side? How exactly do the AOT object caching and G1 garbage collector changes translate to better performance for containerized workloads?
Yes. I mean, this is one of the good things about Java, is that if you're looking to improve the performance of your applications, just keeping up to date with the latest version is always going to be something which will give you a free performance improvement. The OpenJDK engineers, they're always looking at ways that they can improve the efficiency of the way that the JVM works. And outside of some of the big things that I've talked about here, so like the G1 garbage collector and the reducing the synchronization that's required for that, to get a little bit more detail about that, it's where you have to get to what's called a global safe point. And that's where all threads are at a common place where you can then take action to perform the garbage collection. Sometimes that takes longer than necessary because of the synchronization that needs to happen between those threads. So what they're actually doing in this JEP is to reduce the amount of synchronization that's necessary so you can reach that global safe point, as it's called, quicker, and that then reduces the time that you have to wait for the application threads to do their work and reduce the overhead on that. But what you do find as well is that in terms of the development of the JVM, there's a lot of small things that get included. So even though I've outlined 10 JEPs, as they're called, there's also a whole set of other changes which come from very small things that may be bugs that are reported or things that people have identified as a way to improve efficiency or performance. So all those things collected, once they're delivered into the JDK, that means you get a bump in performance. So in terms of the overall approach, yes, if you're talking about containers, because you're typically going to be doing a CI/CD type of pipeline for rolling those things out, and you may be doing fairly frequent updates to your container images and your application code or microservices, using JDK 26 can become a practical way of doing things because you're not too concerned about having to update on a regular basis because you're already doing that. So yes, you could decide to use JDK 26. You could take advantage of the small improvements in performance that you get from that and then deliver that to your containerized images.
Java now has a new API for HTTP3. How does this change the game for modern distributed microservices?
Yeah, again, this is about performance because, as I said, the way that HTTP3 works is switching from using TCP as the high level protocol to using UDP. And UDP allows you to be more efficient in terms of the way you send the packets. It still needs to have, there's still a bit of kind of extra stuff that goes on top of that because TCP is what's called a reliable protocol, meaning that you know that the packets that you're sending will be received in the order that you send them in. And there's a degree of a resend if necessary. So if a packet gets lost, it will be resent. UDP is basically an unreliable protocol, which means that if packets get lost, well, that's, too bad. And packets may not arrive in the right order. So HTTP3 has to then build on top of using UDP to give you that reliability. Because if you're sending web pages and if you're doing microservices, what you want is to be able to send data and that data to arrive in the form that you sent it. Doesn't really work very well if you don't get the right data. So it's HTTP3 solves those problems, but allowing you to use that higher performance protocol. So it's kind of a combination of things.
Now, structured concurrency is back in preview again. Give us a sense of the timeline here. How close are we to actually seeing the full realization for Project Loom?
Yeah, I would think that one is probably, it may be a full feature in the next release. Certainly, I would say by the release after, so what that be 28, yes. Certainly by 28, I'm sure structured concurrency will be in there. It is part of Project Loom, as you said, which is one of those large projects like Valhalla and Panama and so on. So we've had virtual threads, we've had structured concurrency, various things like that. So yes, they're kind of putting the finishing touches to the components in Project Loom. I think when I looked at the JEP, there wasn't any significant changes between the previous release and this one. So I would imagine that once people have had a look at that, they're happy with it, they will then finalize that.
Let's talk about Vector API. It's entering its 11th incubator iteration. Talk about what is taking so long. What are they working on?
Yeah, it is because it's part of Project Valhalla. And Valhalla is the idea of value types in Java. It's a big change, although it's not a huge change from the programming point of view. It's a big change in terms of how the JVM works underneath. So it's going to allow better, again, efficiency and better performance because of the way that we can lay out objects. The sort of impact that it will have from the point of view of your coding is it will allow you to do things like have a collection where you can not just have a collection of, say, integer, where you've got the wrapper classes, but you can also have a collection of, or a list of int. So you can actually put primitives into a collection. Can't do that at the moment, but Project Valhalla will allow you to do that. Vector API is sort of related to that. It's all about the idea of using single instruction, multiple data. So true parallelism in terms of processing large numbers of values using the fundamental abilities of the CPU. So you've got these very wide registers. You can load up a number of elements from an array into those very wide registers. They could be 128 bits wide, 256, 512 bits is the widest you get on Intel. ARM goes all the way up to, I think, 4,000 bits in some of the processors. But that allows you to apply the same operation to all of those elements in a single clock cycle. So if you want to add 3 to each of the elements, you can do that in a single clock cycle. That's very efficient if you're doing numerically intensive operations. And so if you're doing things like AI, where there's a lot of maths involved, this can be very, very useful to you. Really, there's not much that's actually changing in there. Last time I looked at the JEP, it's just some very, very minor changes to the structure of the API, but it's just ticking over. Once they deliver the key parts of Valhalla, they will finalize the vector API.
And finally, applets are officially gone. What does cutting this cord once and for all say about Java's identity in a cloud-first world?
Yeah, I mean, Applet is never going to get used in the cloud. So this is all about very, very old code. I mean, it makes perfect sense to remove the Applet API because nobody in their right mind is going to try and write an applet using JDK 26. Nobody in their right mind would have used the Applet API after JDK 11. There are still plenty of people out there who are running applets, but they run them on older versions of the JDK. So they would still be using JDK 8 or maybe JDK 7 or even JDK 6, because those still have the ability to run those applets. But as I said, the problem is that applets need to run through a browser typically, and that's the way most people have used them in the past. But even like the oldest browser, like Internet Explorer, they no longer have a browser that's supported, so you can't get security updates to that browser, which will still allow you to use applets through the browser plugin. So you're really kind of running on a very old system, which you should be looking to move away from if you possibly can, because there's issues of security and potential vulnerabilities that could be exploited there. So it makes perfect sense to remove the Applet API at this point.
Simon, thank you so much for joining me and sharing these insights. The performance gains for containerized workloads in JDK 26 are hard to ignore. So thanks for sharing these insights. And as usual, I look forward to chat with you again. Thank you.
Great. Thank you very much.
And for those watching, if your team is navigating Java performance and deployment at scale, make sure to check out Azul and its solutions. And don't forget to subscribe to this channel, like this video, and share it with the team. Thanks for watching.